Welcome to episode 6 of Generating Conversations. If you are new to our podcast, we are inviting experts in LLM technology from research and industry to talk about big ideas and trends that are shaping the field. In previous episodes, we discussed the core ideas in language modeling, when it makes sense to build or buy LLM technology, and some of the limitations of generative AI. Today, I'm really excited to have Nathan Lambert join us to talk about RL and the evaluation of LLM technology. Nathan Lambert is a research scientist at HuggingFace, where he works on reinforcement learning with human feedback, or RLHF. He's also the author of the popular blog Interconnects. And prior to joining HuggingFace, Nathan was a PhD student at UC Berkeley, where he worked on model-based reinforcement learning. Welcome, Nathan.
Hey, thanks for having me.
Awesome. So I'm going to jump in because you started at Berkeley. Maybe we can start with your background and your story at Berkeley. So in grad school, you took a somewhat unconventional route. You started off working primarily in electrical engineering. And over the course of grad school, you moved almost completely into working on reinforcement learning. How did that transition happen? And what was your experience with it?
Yeah, so I was like in the first wave of machine learning transitions at this point. Now that language models are a thing, everyone's probably rushing again. So undergrad was in mostly the mathematics and hardware side of electrical engineering, and I joined a kind of systems robotics group with the full transparent ambition of, if I don't like my PhD, I'm going to take the master's and do something else. And then I kind of realized that machine learning was a thing, and I was like, okay, this is, if I steer my life in that direction, my likelihood of comfortable outcomes are much higher. As an ambitious person, I think there's a lot of people out there that generally follow that feeling, and it's okay to do that. And my first year of my PhD, I actually went around to all the popular people at Berkeley and was like, hey, can I join your group? And they're all like respectfully no. So I kind of had to take another path, which was just kind of see what opportunities come my way throughout. And then it's kind of a long transition of going from robotics and machine learning. And then with COVID, not really wanting to go into a lab and doing mostly what is like pretty standard machine learning research on model-based RL methods. And if you zoom out over 5 years, it looks like kind of a smooth transition, but if you zoom in, it never really feels like that.
Yeah, I actually went through a similar path as a grad student as well, kind of jumping around in areas. It is true. We see a lot of people in grad school and actually in undergrad as well, kind of moving or gravitating towards machine learning. There's a lot of excitement there, and it'd be fun to get your take on where the whole field is headed these days. You moved towards reinforcement learning, which it is true. Actually, I guess this was what, 2010 or 2010, 2019, 2018?
Yeah. It started in 2017 fall. So that's right when this was all happening.
Yeah. So our reinforcement learning was taking off. A number of my grad students were also moving in that direction. Hopefully you didn't reach out to me and I was one of those faculty that never responded.
Well, people responded and they took meetings with me. They were just like, oh, I don't do that.
Yeah, so there was a lot of excitement about reinforcement learning. I guess I didn't move into it till a little bit later. So what happened to reinforcement learning?
I think when I was there, reinforcement learning was still kind of a metaphor for intelligence, which made doing research on it, if you like telling stories and trying to like think about the big picture of what you're doing, very exciting. And like now reinforcement learning is full on like in a method camp and no one really talks about the metaphors for AGI. So there's a fun fact that like David Silver really had a slide at some like deep RL tutorial at like ICML 2018 or something, where it's literally the slide is like deep RL equals AGI. And we've definitely fallen a bit from there, but it dictated a lot of what people were excited about at the time.
Yeah, I think I actually attended that tutorial. It was a fun tutorial, and I think it's recorded for those who actually want to go back and watch it. Certainly reinforcement learning was kind of pitched as the future, and a lot of the work that we were doing in the systems around AI was moving that way. And then in my experience, it sort of died off. And reinforcement learning, it's still an active area, but it wasn't, the energy moved to new areas, large language models being one of those. And then what was kind of exciting to me, and some of my students doing reinforcement learning work have started moving towards as well, is kind of the application of reinforcement learning in this new domain. And as you've said, it's become like a core method. As I said in the intro, RLHF is one of the key tools, and we at Berkeley argue one of the key factors in the success of like ChatGPT. Maybe could you give our audience, kind of a high-level picture? What is RLHF? Kind of what are the specific steps? How does it work?
Yeah, so RLHF at the simplest level is best thought of as kind of a complicated fine-tuning mechanism for in a data efficient manner, taking some sort of preference labels that you have and integrating them into a model. And the reason why you need to do something fancy like reinforcement learning from human feedback is because doing supervised learning on these preference samples is shown to really not work at all. So if you just try to do a one-to-one mapping, so people kind of came up with this more complex feedback-based approach where you train a separate reward model, or you like fine-tune a value head on this preference data, and then you use an RL optimizer to extract the data. And then therefore you get a small feedback loop that integrates those preferences into a instruction-based language model.
Yeah, it's definitely it's neat. Just to add to that kind of that story, we in my group had been working on this vicuña, all these instruction fine-tuned variations of like base foundation models, and they pick up some of the behavior that we want, and they start to look a lot like the things you fine-tuned them to. I think the excitement around RLHF that I've seen recently also kind of stems from the ability to push that much further and kind of get a better sampling of the space of interactions. If I try to instruction fine tune, I'm limited by my instruction fine tuning data set. With RLHF, I can build a model to evaluate the quality of a conversation. I can have my AI have millions and millions of conversations and then score those and use that score as a way to really boost the quality of my model. But there's a dirty secret in the whole RLHF, and that's the HF part, I guess. And that seems to be kind of there was a lot of excitement when RLHF came out, and again, people have made pretty strong arguments why it's kind of the core to the success of something like ChatGPT or the big commercial models. But it's expensive. Maybe talk to kind of the human feedback part and why that works or doesn't work.
Yeah, I think the word you used, expensive, is the right thing. So now I'm like, in making talks, there's two slides right after each other. One is RLHF is crucial to modern chatbot and language model technology, where it's like there's quotes from papers where people just go off about how RLHF was super important and easier than they expected it to be. But then they don't really include the fact that it's a $6 to $10 million data and infra investment with teams of 5 to 20 people. And that is something that doesn't translate to a lot of academic research groups or startups for that matter. So it generally is like this next phase. And what I'm interested in is like, okay, what is the measurement and kind of methods that need to change in order to make RLHF work at something like a 7 billion parameter language model, and with 1 or 2 people that grab some data sets off the internet and just go for it. And that's still mostly TBD.
Yeah, it's very important that we be able to make progress in this. I would say, again, when I look back at the work we did, like in some sense, you're getting, with a lot of these instruction fine-tuned models, you're getting what kind of matches the instruction data you have. And so lots of high quality instruction data makes a big difference. Getting those human labelers, not just to build a basic data set, but with RLHF to build a model that can then assess future conversations is good. One of the things that kind of struck me as wow when I was reading the RLHF work is that they noted you need to get continuous human feedback. It's not enough to just get human feedback once and get one value function, but as you interact, as the model learns from the value function, you need to update it. Do you have a sense why?
I think this is partially a product of how RLHF is primarily used in chat right now. And in terms of a domain to develop a method, chat is probably one of the worst ones, because like measurement is really hard and complexity is extremely high. And what you're actually optimizing for is like a strict subset of what people are going to then use the models for. So then any like kind of side effects of what you're doing are noticed way more than they would if you were to choose one domain. So I think we don't know exactly what the domains are, but things like code where there's a bit more structure and you could write a better reward function, I expect a lot of the learnings for RLHF to kind of take off on.
Yeah, it's funny you bring up code. There's a big release of a model today from Meta for code. And as soon as I saw that, I reflected back on a blog you wrote. I was like, you know what? We should start applying this work to the models being developed here or developed at Meta. So you wrote a really good blog. For those who haven't seen, you should check it out on RL with computational and AI feedback. Maybe could you tell our audience a little bit about RLAIF or RLCF?
Yeah, so RLAIF, which is reinforcement learning from AI feedback, is the general method that Anthropic introduced kind of buried in their constitutional AI paper. And RLAIF is essentially a broad class of methods where you're using some sort of AI instead of human preferences. And the blog post that I wrote is attempting to generalize that one step further, because essentially all of these things happened at once in one paper with a kind of confusing title and confusing methodology. So I think the point of the blog post is so that people realize there's a huge space to play here, which is we can do RL on any sort of computational feedback. So like examples in popular RLHF libraries on the internet are things like toxicity models or sentiment classifiers. So you really need anything that takes in a piece of text and returns a scalar value from it, where learning a preference model from human data or AI data is one of the more complicated versions. So that's kind of why I tried to throw out a new phrasing for it, which is reinforcement learning on computational feedback. Is just like, this is the umbrella term that people if people want to do research, kind of take a step back. And an example that I like to use is with code. If you're generating code, you can do some pretty basic scoring based on the type of error you get. So like first thing you can check is if your code actually compiles. If it compiles, then you like wrote reasonable Python code, and then you could look to see if there's like a value error or something that actually like interrupts after a certain number of lines. So you can think about reward functions that are like, if you just do a percentage, you could easily get scalar values from 0 to 1 on how much code failed or code ran, and then like negative values for different types of errors. And that's pretty easy to set up. And the problem really is the execution, which is like a distributed systems problem to run code safely in your cloud while training. And that's probably the limiting factor more than the reward signal being too complicated to set up.
Yeah, I love this story. As I said, when I saw Meta had a new code model, I was like, oh man, I want to try this RLCF or RLAIF, though I guess in this case it's purely CF in this setting. Maybe walk me through. So how would I do this? So I need to get a good set of prompts, and then I define such a function?
Yeah, so the hardest part is probably going to be getting a set of prompts that is on code-based tasks. And if you try to do this manually, you'll see, and all the data labeler companies charge a premium on code and reasoning because it's harder to get people that know how to generate prompts on this.
Yeah, there are some nice benchmarks that one theoretically could use, though it'd be the advantage, I guess, of RLCF would be you could support many, many more prompts than you could encode in that benchmark. Though perhaps we can use something like an LLM to augment the existing prompts to kind of generalize them and then try to generate code. Yeah, it's a pretty exciting area. And as I said, people should check out this blog. I think you are right. I think we'll see more and more of RL coming back when it becomes much more tractable using computational feedback than just human feedback.
Yeah, and if you're a close reader of the Llama 2 paper, they have 2 reward models. I have told this directly to people in the Llama 2 paper. I expect you to do this in Llama 3, where your third one is a code reward model. And they kind of were like, haha. So I was like, it might not be exactly like that, but there's a lot of logical things that people in the like at scale RLHF space are looking at to explore.
So moving a little bit in the direction, I guess, of using AI instead of humans as a way to give feedback. Another area that my group has been looking at is interested in is using AI as a way to evaluate AI. So we've been running this fast chat arena, which was a kind of a way for us to get conversations in the wild. It's a mediocre but interesting ranking of models. I guess in some sense it does kind of match what we see in the open benchmarks. That's good news. One of the follow-ons for us was using GPT-4 as a mechanism to directly evaluate models. And we've did it wrong initially and have since slightly improved the method
so
to understand.
We did the same thing.
So maybe, talk through, instead of me complaining about what I did wrong, tell me, GPT-4, how should you use it? Could you use it for evaluation? What are your thoughts on that generally?
Yeah, so I think generally the train of reasoning that most people followed to start with was, we're collecting human preferences by comparing 2 responses and having the human rate one of them with lots of like randomization controls and stuff in the background. And the idea was, in order to maintain the structure of data that you're using for RLHF, in hopes to kind of have a similar evaluation pipeline between your evaluation and then your training protocol, so things can transfer, let's use GPT-4 in the place of the human. And then the big pitfall there is that GPT-4 is extremely positionally biased, especially when kind of comparing 2 answers. And then a lot of different things, and great research from your group later, is that like things like this multi-turn benchmark where you have, I think, a single scoring makes a lot of sense. I'm kind of ready to shop around my next step research idea on these things. In the big picture, MT Bench was super needed to apply clarity to what the global ranking of models is. But if you're trying to use that as a training metric, it's extremely hard because essentially there's two issues. One, it's from 0 to 10, so it's already saturated with GPT-4 at 8.99. And then because OpenAI models drift and then there's non-zero temperature in the generations, you essentially have some amount of variation in the average score you get for MT bench. So like in our experiments, it's like half a point. And therefore, if you look at like half a point across 0 to 10, where you're already in like the 6 to 9 range, there's really little amount of improvement you can do as a training metric. So I'm generally like ready to find people that want to make like chat bench, which instead of 2-turn, you have very long-term sequences of questions. And then at each generation, you have GPT-4 rate the generation. And only if you get a pass fail. And then if your generation is a pass, you can proceed to the next one. And then your total score is the total number of prompts that you get a pass on. So it's kind of like, so you can essentially incorporate a lot more information and kind of complexity. And then I think it would hopefully remove some of the kind of OpenAI like variation problems where like, I don't think the difference between an 8 and a 10 is really that noticeable. Like those are both good. And if you read, like you can go to the space you have and read some of the judgments from MT Bench. And it's like, okay, like if it's close, it gives a somewhat reasonable score and a little distribution, but hopefully the yes or no with scaling difficulty of tasks would work a little bit better and kind of be different. But I have to make this and then actually show that any of my claims are true, but it's interesting.
Yeah, definitely. I will say with the MT bench, is the project for my group. When we built it, the MT was multi-turn. The focus, in fact, our kind of observation early on is that evaluating these models on a single, question answer basis isn't good. It's not capturing the complexity of reasoning, and also it's not really differentiating the models. And so we made it to 2 turns. Here's a challenging task, and then asking a follow-up question: can you refine the task in the following way, or can you justify your answer or provide an alternative explanation? It challenges the models. We did something funny, as you pointed to in our approach, is that rather than saying, we actually did 2 things. We asked the GPT-4 to compare the output of 2 other models, like let's say secretly Claude, it doesn't know which one, Claude and Llama, and say, which one does better. We did a binary pairwise comparison, which gives you kind of weak signal. And we asked it a weirder question, like rate them, give a score of 1 to 10, I think. And as Nathan pointed out, that doesn't. We tend to saturate pretty quickly, and so it's not very good for learning. But yeah, this is an area I think of a lot of future interest. And I like how you've turned these evaluation methods into, in some sense, a tool to improving the models themselves, not just as a way for people to entertain their curiosities of which model is best today.
Yeah, I mean, like ultimately, like the things we've built in evaluation at HuggingFace were internal training tools. Like the language model leaderboard was really supposed to be where all of our automatic evaluations went to populate this. And then it got carried into a whole different discovery mechanism. So now we have the private leaderboard, which is at the end of our instruction tuning and RL runs, it automatically runs the benchmarks and it automatically runs MT bench, and then the scores get pushed to our leaderboard. So like, that's why we kind of look at whether or not this can be used as a training metric, and it's more of like a debugging tool. It's like, did this work as expected? And that's why I'm like as a researcher, ready to move on to something with more signal.
Interesting. So when you kind of reflect on those leaderboards, the big takeaways so far for you are maybe having more challenging benchmarks and more signal, or what would be the things you do differently, I guess, moving forward?
I think there's kind of 2 things. One, we need more diversity of benchmarks. They exist already in the literature, and then it's normally a challenge to set them up to run automatically and efficiently. So it's like engineering work to have automatic benchmarks. And then I do think there's still space to have like harder chat-based benchmarks. I think we're getting there and people are working on them, and that'll provide a bit more signal. It's mostly asking the questions of like, trying to open up the types of things that OpenAI is running and Anthropic are running behind closed doors. It's like, okay, they surely have things that they're like, these are our design targets, and we're just as smart as these people. We're just a little behind. So it's like, we should be able to come up with these too.
Yeah, we've certainly been struggling there too. To like, how do we get more benchmarks, more specific? Like, we want more questions about code, more questions about politics, more questions about science that are more nuanced, and the self-instruct kind of the existing mechanisms to get there aren't pushing it far enough.
Yeah. So like my idea of like chat bench is based off looking on like professional preference model data, and you order in like a conversation of like an average number of turns so you can see how they kind of do it. There's things for math, it'll be like compute this integral. And then if you do it, it'll be like, oh, that was right. How about this harder integral? But they just do that like 6 times. And it's like our models mess a lot of them up, but you can see as the models get better, it's like, okay, you're going to get some reliability metric, and it's just like you can fit a lot into there, but it is hard to come up with them.
Yeah. So I kind of stepping back a little bit, a question that we've asked a lot on our blog and on our podcast here. When you think of kind of how I improve my LM for my specific tasks, let's say I want to improve grading of papers, or I want to improve my ability to complete emails. Do you see the future veering more towards fine tuning, more towards retrieval, in context learning? How do you see these kind of broad trends in LM technology evolving?
The short term is definitely fine tuning. I think short term is like you're better off buying some experts to write data than buying more GPUs for just getting like in domain data of very high quality. Like we've seen that even just 100, or you just have your team do it for 2 days. And that could actually make a big difference if you're in a really niche domain. I'm not an expert on retrieval augmented generation. I could see the kind of retrieval being used in a synthetic data mechanism really easily. So kind of like in this instruction tuning or RL phase, you could synthetically inject internal data with something like retrieval. And then if it's just the data, you also don't have to modify some optimization or inference setup with the different architecture for retrieval, which seems hard. The internal debate of RLHF is like, what is the example other than safety that you actually need RL for? And there's a lot of like mumblings that it's coming. Like people say like Google's doing it with chain of thought, or there's this DeepMind paper where they like use RL to fine tune the prompts. They do something like RL plus context distillation. So they don't actually update the model parameters, but they like fine tune the examples in context to then actually improve it. So there's like a lot of mumblings of the things that are coming, but safety is really still the thing that's most used in my opinion.
So kind of a consequence of that, if the future involves a lot of kind of specialized models, do you imagine a world where there's going to be more emphasis on open source, self-hosted models, or a world where you do all of this by making calls to OpenAI or other large scale commercial vendors?
I see there being both. I think the crucial question is how long of a believer in scaling laws you are. So if you listen to like Anthropic CEO, like Dario, it's like essentially every 2 years you get a 10x in the capital expenditure of models, and then within 5 years we're kind of at the TSMC model where only a couple of companies can afford to make that kind of investment. And if they're still getting huge investments, then it's like, okay, like everyone will either use those models or data generated by those models, and that's kind of boring. I guess like the data generated by them does enable this long tail of kind of smaller domain specific models. And for that reason, I do think there'll still kind of be this long tail. Like Apple will do this type of thing where they're waiting and then they have a hyper efficient model on their hardware and all of this stuff. So I'm kind of in the middle when I get asked this question. I think a few months ago I was thinking about like, oh, definitely it'll be small open source models everywhere, but it depends on this kind of whatever, like foundry like model. Like if that's what AI becomes, it's harder to know.
Yeah, I don't want it to be that way. You're right. There are a lot of economic reasons it could go that way, though. There's hope for us, even if that is the future, because the foundries are well, there is TSMC, but we're starting to see more innovation at least at the chip design level. So maybe the same will hold for AI in a few years.
And the foundry outputs are not readily usable. Like the chips don't retrain other models, where the model outputs would be extremely useful.
Cool. So maybe I want to wrap up because you've actually done in the short time built up quite a following in your communications around AI. So you've been writing a blog. Tell me kind of your secrets. Like, how do you make a vlog so successful? What's the trick?
I think you kind of have to do like 2 or 3 things. There's consistency is definitely something that people know is required, but it's not easy to do. So kind of setting expectations for yourself and the people that are reading and or considering reading, and then consistency brings them back in and kind of builds that distribution network. So like I do Wednesdays and try to tell people if I'm not going to write. And then branding is, you just have to stick to something that's branding and related to effort. So you have to stick to something that's not too hard. It's like I don't like to do deep research-based writing because it takes about like 4 times as long if I have to go try to read a couple of research papers to actually get my ideas out, versus just writing what I'm thinking about. And then it's kind of like a useful process of distilling your ideas. And it's like I have to go add links, but it's not like I'm searching for an old paper that I read. I'm like, okay, I'll leave that to the reader. And that just makes it much more lightweight, which is sustainable. I mean, if anyone wants, like, all the like information-based social media things are all about posting consistently over a long period of time. And I think most of people here, like you or anyone in this network, has interesting things to say. So if you just consistently put it out there, you'll gain a following. It's just very boring and takes a really long time.
Yeah, it's funny. This is something as faculty we don't think about. As academics, it's not really our focus, though it should be perhaps, because there's a lot of discussion going on in the AI space today. Not all of it makes sense, and trying to stand out and get a clear message as you've done is important, and you've done a good job at that. Maybe I want to wrap up on a kind of a fun last thought. As I said, there's a lot of noise out there in the AI space. Do you want to in your mind, what are the kind of the key points of confusion that people are kind of misunderstanding about LLM technology and where it's headed?
Yeah, so I think generally, if we go back to where we started this conversation with grad school, when I joined Twitter, everyone was publishing threads about the stories of their papers, which was really nice for like information retrieval. It was there, but also for like relationship building, because you're interacting directly with authors in your field. And like, I have made real friends through that in real life. And now there's 2 pressures of information distribution. One is those algorithmic feeds are pushing kind of more centralized actors on the research side. So there's a lot of people that gained a lot of influence by sharing papers on a consistent basis. And they're doing this thing of posting regularly to build a following. And then the kind of high level public interest coming down to try to engage in the research realm. And I would probably lean on the side that says that the discourse and progress in AI is still technologically driven, where the research ideas are still probably the most important things that are coming out in terms of making short-term forecasts. Any forecast is not really useful outside of 3 to 6 months right now, where you're most likely to follow that by reading papers and going to dinner parties in SF. And then I kind of wish there were different mechanisms for participation in the narrative from machine learning authors and academia and things like this, where most of the distribution is through centralized channels that kind of remove author voice. And that's something that I think about, what is the right medium for promoting authors other than just like retweeting or whatever. And it's like, how do you capture that correct motivation and story behind a work when you're going to have mainstream writers comment on what they think this work means and often get it wrong, and kind of how to build this trust mechanism. So I have a question that I ask myself is a scientific paper a reasonably good mechanism of building trust in AI from transitioning from research to the public domain? And if it's not true, what should that look like when everyone's trying to participate?
It's a great question. I'm so glad you said that research is still important, but also you raised a very good point that writing papers is maybe not the way forward, as we try to educate the broader world about what's being done in the space. Well, Nathan, it's been great having you. It's been a fun conversation. I encourage people to check out your blog. It's awesome. And look forward to seeing more of what you have to say.
Yeah, thanks so much for having me.